First of all, thank you guys for coming out to my talk. I'm going to be talking about how my company SignalFx uses Salt as the tool to serve our needs in infrastructure. My name is Warren Turkal, and I work as an SRE at SignalFx now, but I've worked at places in the past like Google and Ayala. I served as an SRE for Borg at Google. So I am basically an infrastructure hacker at SignalFx, and I'm also our resident AWS expert. So, having said all that, let's get this thing underway. So, I'm going to talk about a number of things, but the first thing I want to do is I want to kind of give you at least a very short version of what SignalFx is and what we do, just so that you know where we're coming from, and after that, I'll talk a little bit about how we organize our infrastructure. The how is very much driven by the tooling that we use, so I'm going to talk a little bit about that afterwards. The next thing after that, I will talk about why we chose Salt Stack, which there's a lot of functionality in Salt Stack, so I think it's interesting. I've talked to a lot of people that have chosen it for a lot of different reasons. And then I'll talk a little bit about how we actually integrate Salt with our infrastructure. There's like the normal stuff, which is just, writing config management stuff, but there's a lot of other pieces that we've kind of gone further in order to make it work a little better for our purposes. And then we'll talk about some practical choices that you need to think about when you're running Salt. So those are pretty important. And talk a little bit about how we monitor it and take a little bit of Q&A afterwards. The very first thing, so my marketing people made me do this, so I'm going to, but I think that it's, I think that it kind of shows where we're coming from. So SignalFx is a real-time monitoring analytics platform. You can imagine never having to configure your own monitoring service, just send data to us. I've been with SignalFx since December of 2013 when we had no production. Now we have many more thanks to a number of our customers, and it is what it is. So with that out of the way, let's move on to something a little more savory, so to speak. The first thing is how our infrastructure is organized, and it's kind of like an onion of organization. The very top level that you are looking at is something. It's a region, and it's just like the region in AWS. So for the most part, our infrastructure runs in AWS just because that's been convenient. There's nothing particularly AWS specific about it, but we identify a region with the service provider, AWS, and the region name from the service provider, like US East 1. Inside each of the regions, we set up one or more cultures. So you can see there are two in this one. Those in AWS, this is basically a VPC, and if you're familiar with that technology, the culture has a lot of objects with it, but the really primary one that you need to be thinking about in terms of thinking about it is the VPC. It also includes around 24 distinct AWS objects, things like network ACLs. Instance profiles, things like that you need to kind of run stuff inside the culture. In AWS, we control this with a dynamically generated CloudFormation. I'll get into the tooling about how we do that in a little bit. Inside each culture, we have something called cells, and culture of cells. So inside each one of these, we basically set up a cell into each availability zone. The idea is, well, I'll get a little bit to that later, but they run in an availability zone. A cell basically corresponds to about 92 different AWS objects, and again, that's generated by a dynamically generated CloudFormation template. So, how many of you are familiar with AWS, VPC and CloudFormation? Do all those things make sense to everyone, or? All right, so I'm just going to very quickly say VPC is a technology for basically running something that looks more like a private network in AWS, and CloudFormation is basically, think of it as I submit a JSON file and I get some stuff set up. So it's kind of like orchestration on a light level, but it's a pretty static configuration. Inside each of these, of course, at the bottom of the stack, we have to run hosts somewhere, and that's where the host command is in the cell. So as far as like when we're thinking about where a host runs, a host runs in a cell, which is in a culture, which is in a region, which is in a provider, but the provider is kind of part of the region. The way that we currently have this set up, we have only one production culture in each region. Each cell is capable of supporting about 4,000 hosts, barring any unforeseen scaling issues. We haven't run into any yet, but and if we run one cell in each AZ, this would mean that we could support up to 16,000 hosts in US East 1 alone. So just to give you an idea, because there are 4 AZs, 4,000 apiece, and there's some methods that we could scale it higher, but that's currently the way it's designed. So the point of all of this design is to make sure that the cells fail independently. So like when one cell fails, it's not going to bring down an entire culture with it. You don't want a cascade of failure. You just want something narrowly focused, as narrow as possible. It also, like one of the real guiding principles of this is that TCP/IP between every host, because I don't want developers having to like set up a proxy to make Cassandra talk across regions or something like that. So basically, it looks like a flat network inside. So if I log into a host, I can ping any other host in our infrastructure, at least as far as the network's concerned. We also wanted service centers to be able to affect the placement. So if you've ever run an AWS or any other cloud provider, you know that there are costs associated with traffic going between regions or going between availability zones. We needed to be able to expose this to service owners so that they could pick, whether they wanted, lower cost or better reliability, for example. And so, for example, you might run within a single culture, which is in a single region, or you could choose to run in multiple cultures in multiple regions. And of course, that's going to cost more because now you're talking about traversing the public internet and public IP space. So if anyone is more interested in like kind of that network setup, I'd be happy to talk about it afterwards, or you can check out this this QR code that I worked hard on. Anyway, so and I can pull that up later if anyone's interested. So the thing. Let me see. So there's also tooling that is kind of on top of all this. So we have a pretty extensive provisioning and environment maintenance tooling, which lives in a project called SF Infra, obviously named after my company. Naming is hard, not the best. I feel like the hardest thing in computer science is naming things. So non-SRE owners primarily use 2 of these tools. So SFLB for managing LBs and SFHost for managing hosts. The tooling ensures that hosts, when they come up, they're brought up in a particular way, so they're tagged in a particular way. And because they are reliably tagged, we can rely on that information when it comes to using that information for configuration purposes. And this is basically where our Salt integrations come in largely. So here's the salty info you finally came for. So for the rest of this talk, it's important to note that we actually run a master in our setup. So there are a couple ways that you can run Salt. You can run it with a master, or you can run it masterless. We use a master setup. There are advantages and disadvantages, but one of the advantages is that the pillars, the pillar data, which is data that can be sent off to various machines, doesn't necessarily get shared among all the machines. So if you have secrets, you can store them in the pillars and safely kind of understand that it won't end up on every machine. So TLS keys, things like that. Okay, so having said that, here's the things that I liked about Salt when I first found it. I'm a Pythonista, and it's written in Python. So that was actually nice, because I can go in and I can debug it, like when I have issues with it, and I've never met a piece of software that I haven't had an issue with. But this makes it pretty approachable for me to debug. It also means that it's also extensible. And I looked around at a lot of the different solutions for config management, and the extensibility of Salt was just nice. There were a lot of places where they allowed for kind of plugging in additional functionality, and we take advantage of that pretty liberally in our system. So it's a few very simple ways that we do it, but it's like kind of broad across the system and makes it where things work a lot better. And of course the ponies. There are so many extra like features that are interesting. So it can use Git and other backends in the repository for both the pillar data and the file serving, which is where the config info is stored. It's really nice to be able to just configure a Git repository and have it do the right thing and not have to worry about how I'm going to sync that to my server. Another thing that I think is really interesting is that it's multi-master. And this is something that kind of drew me to it at first, although when we first used it, it worked, and then the functionality stopped working, and I don't know what state that it's in currently. I'm pretty sure it's back to working because it's been a while, but we didn't actually need it for scale, so it wasn't that stopped us from using it. There were some other issues. It has orchestration kind of built in, so that orchestration allows you to like do things across multiple machines with kind of like global knowledge. So when I'm on the master, it can kind of make sure that it's only operating on one machine. That was kind of interesting to me. In our setup, we actually don't use this very much because we use Docker and we use a different layer for orchestrating Docker pushes. And that tool is called Maestro NG, and it's actually written by one of my coworkers. His name is Max Petazzoni. It's actually a pretty cool tool if you're looking to do like a very static Docker implementation where you have like specific ships and want to run specific containers. And we developed that. I mean, we started using that tool a long time ago before a lot of the kind of newer frameworks that you've seen come out. So it's kind of a different approach. Related to orchestration, there's this thing called reactors, and reactors are actually really cool in Salt. Reactors allow you to see an event, say a machine connecting to your Salt master for the first time, and actually react to it. And that is actually a really interesting piece of functionality. We haven't tapped into this too much because our use case is basically boiled down to like, just a periodic run of the config management, but there are a lot of places where this kind of functionality could be extremely useful. Like if you push a config change and want to deploy it immediately, like there are ways to kind of see that the file server has updated its configuration. Now it knows that it needs to launch a config change on all the machines that would be affected. Again, were we not running Docker, were we using more of the orchestration, I think that would make more sense for us. And it also has this concept of multiple environments. This is another thing that I thought was interesting. These have promise, but we found the feature somewhat difficult to use just because it's not straightforward to stack a number of data sources together to create these environments. It can be done, but it kind of has to be done manually. So, but the idea would be that you would have, say prod, and then like stacked on top of prod, you might have a staging so that it could override things, and then you'd have a staging environment where it's prod plus this other layer, and then once you qualify that, merge that back into prod. That is currently something that I would like to see. So, talking a little more about how we've actually integrated into like taken Salt and like integrated it into our system. So the SF host tool that I told you about before, it does a lot of tagging to AWS. So when we start an instance, it gets tagged with the service. It also gets tagged with something called a service ID and the cell that it's running in, so that we can, look at those attributes and see what's actually happening. So Salt has this concept of grains, and if you're familiar with Puppet, you might know it as facts. And pillars is more like data that gets shared with the system. I'm not sure what the Puppet terminology would be, but it's something like similar to data bags or something like that for Chef, if you're familiar with those pieces of software. So what we do is so for the grains, we actually pack all the information about EC2, instance ID, and some other EC2 information. We add those as basically these grains, and then we also add some of that information to the pillar, so it's available in both places. And the nice thing is you can use that data to select machines. So if I know, for example, that the pillar is set by my master, and I know that that pillar is set to service whatever, I can use that to select particular machines to apply the right configurations, which is basically how the tags map down from AWS. You set a tag, that tag gets mapped into one of these pillars. When the machine is selecting its configuration, it looks at that pillar and then selects the right configuration based on that. And the nice thing is that lets me deal a lot with kind of more convention. We don't have to deal with a lot of explicit configuration there. There's more integration if we want to fully wipe away all of the configuration, but that helps in a lot of ways. So another way that we've integrated with Salt is we've written some custom state modules. And custom state modules are the way that you tell Salt how to configure a new thing. So there are two kind of significant ones that we've done. We've done some others, but these are the ones that are the most interesting. So HA proxy and SSH. And the HA proxy integration that we have, it uses those same services that we use for everything else, starting with SF host. Once you declare a service, now HA proxy can use that service to pick out its backends. And assuming that you are, careful about how you restart your HA proxies, because it can matter depending on if you're doing consistent hashing or not to the backends, then you can make that kind of work better for yourself. So basically what it boils down to is I can spin up something that is an HA proxy-based host and expect that it will be fully, like 0 to configured in about 10 minutes. And and we're not using like custom AMIs or anything like that, so that includes like machine bring up, applying a user data, script, rebooting the machine to make sure that we're in the latest, kernel, and everything is up to date and running, and HA proxy is ready to go. The other thing that we did, like I said, was the SSH integration. This is how we deploy our SSH keys. So the built-in way that you can kind of do SSH key management in Salt is, it's kind of cumbersome because it requires a lot of like metadata about the keys each time. So rather than doing that, I basically wrote a module that uses one of our Git repositories where we were storing SSH keys in a certain kind of structure. And we can deploy those out to various machines. And the really cool thing about it is you can say, there's a group of keys that gets deployed to every machine, but there can also be keys that are only deployed to certain services. So everything is really keyed on this idea of a service, right? So when you say that my machine is an analytics server, like that means something to a lot of different systems in our infrastructure. And it means that like you're not having to explicitly call that out in every system. Like when you want that role, you just say start a machine in that role. And the SF host tool makes it pretty straightforward to like spin up those machines and just you just pick a cell that it goes into, you pick a machine type, and you pick the service, and it's pretty straightforward. All right, so in terms of the practical concerns that we, these are probably more design choices that they were convenient at the time, and we haven't really had much of a need to change these. One master per culture. So earlier I said that we had gotten burned by multi-master. We were running multi-master early on, and it turned out that there was a release that on Amazon Linux at least did not function correctly with multi-master enabled. We ended up disabling that version, but we never re-enabled it, primarily because we've not gotten to the point where we've scaled to the need for that. So, and it's not for lack of trying. We have many machines. Another interesting thing, and the other thing that's nice about that, actually, kind of a nice to have, is like because there's only one master in each culture, it's pretty easy to see what the master thinks is going on because there's only one place to look. Salt does have a way to kind of aggregate masters up and like provide a more global view. Because we're in this situation where we're only running one master, we haven't really needed to do that. So, in our setup also, we needed the ability to bootstrap a master from a different culture. So if I have a culture and I have another culture that I'm standing up, I need to be able to, add a Salt master so that I can start bootstrapping machines. So the way that we basically solve that is we allow any Salt master to stand in as the Salt master for any culture, which also means that if a culture has its Salt master die, if it's terminated by AWS or whatever, we can just direct it to another culture. So that's nice because the only cost then is like basically the transit over the network. And if we have a big enough culture, we can even run a second Salt master that's basically a cold standby. So it really depends on how fast we want it to come up. Like the HA proxy issue, when I stand up a new Salt master, assuming that it can, that it has all the plumbing to talk to another Salt master and bootstrap itself, again, only takes about 10 minutes. Like it's a pretty straight, pretty fast process in terms of, doing anything with it. And it's also not a manual process. You just go sfhost add saltmaster, and it does everything that it needs. So there's also kind of like a disaster recovery and even kind of an avoidance standpoint. Our ability to bootstrap from another culture is how we deal with this. Kind of mentioned that already. It's also a good reason to look into multi-master, but again, I think that the scaling issue is a more important issue for the multi-master. And another issue that I found is that most of the public formulas that I've run into, so I know that Chef has a number of community maintained recipes. Salt has something called formulas, which is very similar. Puppet has modules. I've found that in all of these communities, there are lots of really interesting modules that are really flexible, but they tend to be very complicated. And in the case of like what we are doing, it's usually like lay down a config file in a directory, restart service. It's not usually something where I need to be able to specify every Apache command line, every Apache configuration option from a YAML file in my config management. So in general, we actually don't use public formulas for that reason. And it simplifies things in a lot of ways. It also allows us to take a lot of liberties with how we use, like how we do things across, like when we have multiple things happening, we don't have to worry about like ill-intended effects, between these recipes and like being in a pickle when like we have to figure out how to deal with that situation. Do we commit a public patch? Do we keep a patch locally? We don't have to make any of those decisions because it's in general our formulas just turn into like deploy file, restart service, and I mean that's most of the things we've had to deal with. There is another issue of monitoring. We are a monitoring company, so you probably knew that I was going to bring this up. But one of the things that I've done is I've written a collectd plugin for Salt, and this collectd plugin has a couple of major metrics that it looks for, and just gives me that I have a dashboard where I can take a look at this. But current high state's longer than 5 minutes. So high states are basically the config management runs, and what this means is that my config managements are, if I see that number start spiking, then I know that something's gone wrong and something's not working in my salt master isn't responding to to minions anymore, or or something else has gone wrong. This was a much bigger problem in the past. It's not as much of a problem anymore, thankfully. Salt has actually, as a project, has done a really good job of scaling the number of clients that they can support. So when I first started using Salt, you had to add a bunch of timeouts and delay parameters, and you had to add all these manual tweaks to actually get it to talk to more than, say, 30, 40 servers. Now it scales pretty much on its own up to the very limits of what the Salt Master can do. I've only scaled this to the size that we are right now, but I can tell you that it's many hundreds of servers and that we are not seeing any real issues, and we're not on the biggest instances in AWS either. The other thing that we keep track of is the number of nodes down. So that's the number of nodes that the master considers down. And if we see that number staying above 0 for a long time, then we know something bad has happened, because we know that those minions are no longer communicating with the master. In newer versions of Salt, it's even better, because the master, in the version that we use, the master actually has to reach out to all the minions, get a response. In the newer versions, they actually keep track of what they think is connected. So you actually have a really good idea of what the master thinks is connected, although the number will usually vary a little bit depending on how much load you're putting on it and whether a minion's doing some other work. In general, it's pretty close to 0 though. All right, so in terms of work for me, things that can be done, there's a lot of other integrations that we could be doing. So master tops is the thing that allows us, so there's an extension place and point in Salt where you can say if you have these attributes, then I want you to include this configuration data. Master tops is the mechanism for doing that and automating more of that, so that we end up with automatically applied base configurations and configurations based on services without someone explicitly calling out to that configuration. Is something that that we definitely want to have, because I'd like it to be that if someone's just setting up a normal host that doesn't have any special configuration, they don't have to add a file. Currently, as it stands, we have to add something to the pillar, something to config data so that it knows how to configure those machines. And I feel like the less of that is required, the lower barrier there is to like spinning up these machines, the better it is for everyone involved. So salt stack packages. So the company that drives salt stack, they have their own packaging. That's newer. We currently use EPEL packages. I'd love to drop our custom EC2. They've added some extensions to actually get that information and do it in a way that presumably would be more acceptable since it's in the salt distribution now. And investigating multi-master again, I think is just a prudent thing to do because I think it's the right thing to do in terms of like just being ready for a disaster, so that like if something were to happen, then the system is kind of self-healing in the sense that like it would fail over to another master and just let me know that something's going wrong rather than stopping provisioning of a machine, for example. And there's also some features that I would like to see. The most important ones are like stackable pillars. So I'd like to be able to see pillar. So right now you can run multiple pillar modules, but what would be nice is to be able to run a pillar module and then see the pillar data that is injected by that module in subsequent modules so that you can use that to make decisions. And that would be useful just so that like all data that kind of drives the identity of the machine could be driven from the master rather than coming from a minion. And there's also like the master tops that I talked about before. That functionality exists for salt files or for the file server backend. It doesn't exist for pillars, and it would be nice to see it there also, just to kind of find it, take another place where rather than having an explicit configuration, just using that convention. And really that's about it. I mean, the conclusion here is that like our tooling is bringing up all of our systems in a way that like we know how it's going to happen. Salt has lots of extension possibilities. We take advantage of those a lot to like make sure that the way that we set up our machines can be used to drive the configuration of those machines. Salt has taken us from 0 to 600-ish hosts in each culture with a lot of automation. So, that's a pretty good number for each machine. Like we think that we can probably take that a fair amount higher before we have to. Before we're forced to, for scaling reasons, run multi-master. And I mean, in the end, Salt is working pretty well for us, and that's why we continue to use it. And it's been something that I feel like just the way that we've been able to extend it and kind of like plug those little bits of functionality in has made it just that much easier for my service owners to go in and start a new instance of their service. So, and that's really all I had to say about Salt. So thank you. Feel free to look me up on Twitter. Come and see our booth. Like we have a really cool demo right now. We're demoing some new features, and come talk to me about Salt because I could always use new ideas, and there's lots of different ways to kind of take advantage of this stuff. So, thank you very much. So, I guess there's a couple minutes for questions if anyone has anything, or we can chat afterwards. All right, thank you. Oh.
I missed the first couple minutes, but I'm not sure if you covered, in your opinion, Chef versus Salt. What would be your pros and cons? Or I'm not sure if you have any experience with Chef, but
I do. So I mean, I've been through like Chef training, and it was admittedly a couple of years ago at this point. So I'm sure that things have moved on since then. But my impression at the time was there was lots of functionality there. There were just some things about, so when I first was looking into all my different options, like the orchestration did stick out to me, and that's one reason why I kind of leaned Salt. Also, I frankly am more comfortable with Python, so being able to debug it was a big thing for me. But Chef is used by lots of people. It's used by Facebook and everyone else to drive really big infrastructures. So I have no gripes in terms of scale. It's just a matter of the things that I thought that I would be most effective with, and writing these extensions was something that was very important to me, so that my users weren't having to write a bunch of configurations surrounding these conventions. So that's basically it.